presentation covers heat transfer analysis with examples using the lump thermal capacitance method, LCM in short. The first example is about Dr. N, who was visiting an exhibition in an art gallery in town as it opened at 10 a.m. when she was immediately called upon to investigate 2 dead bodies found in the room. The police asked her for the time of death in order to identify the suspects. A human body may be considered as a water cylinder with a normal body temperature of 37 degrees C. Yes, 70% of the human body is made up of water. The room temperature was usually maintained at 25 degrees C with the convective heat transfer coefficient H at 80 watt per meter squared per Kelvin. Based on the information given in Table 1, what is the time period that the police should look for the suspects within the premise? Dr. N is supposed to assist. And then, however, Dr. N informed the police that the time of death was just an estimate assuming small internal body resistance to heat conduction together with a few other assumptions. What assumptions had she made to estimate the time of death? Finally, determine the validity of Dr. N's estimate based on her assumptions. Here, I have highlighted time of death and time period to indicate, to focus your mind to the transient problem here. So in Table 1, we have 2 bodies. The first body was found at 35 degrees C at 10 a.m. The second body was found at 30 degrees C at 10 a.m. So the second body is probably dead for a longer period of time compared to body 1 because initial temperature of a normal person is 37 degrees C. So where shall we start? Sketch, of course, and write down all given information. So we have here the information for body 1 and body number 2. Body number 1 found at 35 degrees C, body 2 found at 30 degrees C. The height and the diameter are different, but the rest of the information are the same. So we have the usual assumptions: steady state, body is treated as water, small temperature gradient within each body, temperature change which is within each body is considered uniform, constant thermophysical properties, neglect radiation. Wait. It shouldn't be steady state because you were asked to determine the time of death. That's definitely a transient problem. We look at the lump capacitance method to estimate the time of death. And from the textbook, you have equation 4.4 for time, which is a function of the logarithm of the temperature difference ratio, and tau, or 1 over b from your textbook, whichever you decide to use here. And we have b here, h over rho Cp, characteristic length in the denominator. Characteristic length is just V over the surface area. First, you find the characteristic length for body number 1 is found to be 0.2 meter. And then you go ahead to find the properties of the body, which is assumed to be 100% water. There at 35 degrees C, you may find the density, specific heat, and thermal conductivity of the first body. With all the information collected and listed, you determine B1, first body, or 1 over tau 1. And it is 9.612 times 10 to the minus 5 per second. That's the unit for B. Unit for tau is just second. You will substitute into 4.4 and you will get that the time of death is about 31.6 minutes ago from 10 a.m. when the body was found. So, dead within the last hour. The police should be looking at suspects between 9 a.m. to 10 a.m. That's for the first victim. For body number 2, from the same appendix as you found the information for body number 1, for saturated water, you collect the information, this time at 30 degrees C, for the density, thermal conductivity, and specific heat. Then you find the characteristic length for body number 2, substitute into equation 4.4, and you find that the value for B2, substitute into 4.4, you have find that the body has been dead for 2.1 hours before 10 a.m., which means the second victim died within the last 3 hours. The police should look for suspects within the premise between 7 and 10 a.m. So suspects that is involved in the victims, the 2 victims. Now, Dr. N, however, told the police that the time of death was just an estimate, assuming small internal body resistance to heat conduction, together with a few other assumptions. What assumptions had she made to estimate the time of death? 3 hours ago, the time of death. and then determine the validity of her estimate based on her assumptions. Assumptions: conduction resistance within the body is small compared to the convection at the surface. The temperature within the body is uniform. Radiation effects are negligible. And then to determine the accuracy of the lump capacitance method, you have to determine the BO number. Small BO number means it's a good estimate. And you substitute the values of the characteristic length, convective transfer coefficient, and the thermal conductivity. You find it is 26, very much larger than 0.1 for a good estimate. So this is just a rough estimate. The body now has to be taken to the hospital or to the investigation room to be further examined. Now, for example 2, in the heat transfer analysis, transient problem, again the lump thermal capacitance method. This time, again dead bodies, but this time is meat. In a meat processing plant, thick slices of lean beef that are initially at 25 degrees C are to be cooled by passing them through a refrigeration room at minus 11 degrees C. The heat transfer coefficient in the room is very low, 1 watt per meter squared per Kelvin. Now, if each slice of beef may be approximated as a 2 cm cylinder, 40 cm in length, and then it is to be cooled to 2 degrees C, determine how long the meats should be kept in the refrigeration room in minutes. If you, as the owner of the plant, is asked if the plant could process veal or lamb, which of the meat type would you agree to without changing any controlling parameters of the plant? Justify your answer. That means, instead of beef, you want to process veal or lamb. So, which one? Suggest 2 ways you could shorten the time for the beef to stay in the refrigeration room. Justify your answer. The first thing is to have your assumptions or a sketch. In this case, we have one-dimensional conduction in the radial direction, constant properties, lump capacitance method may be applied, radiation is neglected. And the sketch, remember the beef can be approximated as a 2 cm cylinder. 2 cm cylinder means diameter is 2 cm, not the radius, with a length of 40 cm. There you have your sketch with all the information provided, and you use 4.4. First, you have to determine the characteristic length, which I've highlighted in red. You find it to be 0.04 meter. Next, to find the properties of the lean beef. Here, you may find the properties of lean beef, the density, thermal conductivity, specific heat, as well as lamb and veal. You collect the properties of the lean beef at 300 Kelvin because that's the only properties, that's the only temperature you can find properties of, no other temperature. And substitute into 4.4, you find that to be cool to the temperature required, time should be 43.7 minutes in the refrigeration room. Now, if you want to process veal or lamb in the same plant, which of the meat type would you agree to without changing any controlling parameters of the plant? Now, if you look at the properties of veal is closer to the lean beef, with the density, the thermal conductivity, and the specific heat capacity compared to lamb. So, it would be veal with almost the same density and conductivity. To suggest 2 ways you could shorten the time for the meats to stay in the refrigeration room, well, smaller size meats means larger surface area per unit volume, and increasing age will encourage heat transfer.